What is up, everyone? Welcome back to our favorite um, game dev tutorial. We are still working on our shitty game, and we're gonna pick off where we last left off. So this is what we had last time. We had a moving ship, and we were able to shoot projectiles. Okay, pretty good. Now in this tutorial, or you know, video in which I'm just showing you what I'm doing. We are actually gonna add in an enemy. I was thinking maybe that would be pretty cool. And I just observed the fact that I didn't change the name of the window, so we have to do that because that doesn't seem professional. So let's do that. And also, instead of making these paths completely absolute, let's make them relative to our working directory, which I'm hoping will be this path, maybe. I don't know, let's see. Probably. And if you are asking, can I maybe open up photos or images on my PC like a normal human being? And the answer is no, I can't. So I don't know what I did to my setup. I don't have the mental capacity now to deal with this, so I just searched up for a online pixel art editor, and I simply opened an image there. So here we have this amazing enemy, and this should be like the sprites that make up its, I don't know, idle animation, I suppose. We will see. So for now, we are just gonna implement maybe only the first image, and then we're gonna make it so that we can have animations. Okay, let's see. Let's build this again. Let's see if our paths work, and they do. Let's change the title. This is the amazing shoot them. Okay, that seems really professional. Let's go on and create an enemy. What do you think about that? Let's go on, create a new class called let's see what name it has. Alan. Okay, let's just say enemy simple for now, and we can go on from there. Let's copy some code. That's not actually the file here. I have the webcam covering this area here, so I can't see the first tab. I'm just letting you guys know, So enemy simple. It's a game object. It has a texture for now. Later on, we'll make this an animation. And let's get a constructor here, and let's create a source file for this guy, just like we did for every other class. Enemy simple. Let's try to do that. Ultra instinct dragging there. Let's do it like that. Is it the first? Yeah. So enemy simple. Replacing stuff. Okay. This is the same exact thing. Here we have enemy simple.hpp. We don't care about input here, and we also don't care about input in player projectile. Doesn't need to know input, at least for now, I guess. And here, let's say enemy simple, and let's import the texture for it. which should be pretty simple using our made up system. And let's see, enemies, and this is the name of the file. I'm gonna assume it's a PNG just like the rest. Let's take the name from here, put it here. Great. Now we have this simple enemy which will just move like a bullet, which we don't want. Now we can make it move in a more interesting fashion. For now, we will just make it move from left to right. So a very interesting thing that we can do here is, well, we have multiple ways of doing this, but I think the nicest way, well, I don't know if I should call it the nicest way or maybe just like a simple way to implement it. So if we use a sine wave, what's gonna happen is a sine function will alternate between -1 and 1, right? Depending on how fast we are actually increasing the value inside. And so what's gonna happen is we can just clamp it to go from from one place to another. So yeah, well, I wanted to run the game so I can show you there, but let's see, where do we have that? I don't know, it's here maybe. Here we need a m time, and m time will simply keep track of time like that. Where do we have it? And time, let's initialize it to 0 here. So let me show you what this means in just a second. Let's add in one of these enemies, and you will see now it's not gonna move right, but we will have a place to start from. Enemy is simple. Guys, I know you like these tutorials, right? You're not lying to me. Okay, let's put them in screen width divided by 2, which is not exactly the middle because of how we handle the rendering of the texture. Our texture is actually, so our position is actually at the top left of the texture, so the middle of the screen will actually render our texture like that, right? Because this is the middle, and from here we start drawing. If we want the middle to actually be the origin of the image, we can do a couple of things. We can manually move the image half of its width to the left and half of its height up, and then we will reach something like this, right? Or, oh, and now I just observed the fact that our texture is like the entire thing. So let's only pick up the first texture, which is from 0, 0. We pick up 16 by 16 pixels. And also, let's make it so that this moves 10 times as fast, right? Just like that. Great. So what's happening is if we move it to 0, it's gonna move like that. Nice. So we can use like a sine wave to do the movement, and we can change the parameters so it actually moves for a longer distance, I suppose. Or what we can say is that, 'cause we can have like a method that will tell us if we are outside of the screen or we are about to reach the outside of the screen, and then we should start moving the other way around. For now, what I think, and now we are basically removing half of its speed, like and we also remove, so how fast it's changing the value, it's defined by how, like what we have here, because this is the value, from inside the sine function. So it's how fast it actually changes, like polarity, let's say. And this is, how much we want to change this, because here we get a value from -1 to 1, right? So, yeah, anyway. Let's see, how do we want to do this? We can also implement a sort of collision. And, this is a pretty simple game. So we are gonna make collisions way not cheaper, because they're not gonna be cheap at some point, but in a much simpler manner. So we can also implement the movement. So I'm just gonna show you like alternatives if you're curious. And you can do whatever you want, obviously. So if you want to use this M time for movement, what we can say is that we have like a direction. So v2m direction. Also, this is not a good movement system, let's say, by changing the position directly. What we would need at some point is like a sum of forces, right? And we would have like a velocity which is equal to the forces divided like by the mass of the object, to have a more I don't know, refined movement. Although this is still not good, but we're just making a shitty game. We don't have to make a good game. So let's just change the position directly for now. Let's remove this thing, and we actually, what we're gonna do is use this m direction.x times m speed. And so this is the direction in which we are gonna move. And this m direction will change when the time reaches a certain threshold. So if 100 milliseconds passed, we are just gonna make this the direction invert. We're gonna negate the direction, and we can initialize here the direction. So this, let's say it's 1 0, so it only moves horizontally on the x-axis. And so what's gonna happen is, oh, actually this is not, it's not good. What we should do is also reset the time, and we should also make it so that we are doing it every second, maybe. Yes. Like that. So yeah, obviously we can decrease this, maybe half a second. Why it didn't change? Okay. Okay. And so we can spawn them randomly outside of the screen, and we can just tell them to go down, right? And we can add more of these patterns. We can use more trigonometry to make them move like in circles, or stuff like that. And we can do all that, but for now let's just keep it simple. screen width. Now what's gonna happen is it's gonna go from there. I'm not sure I like that. And we can refine this system. I can play around with logic, but whatever. Okay, let's make it so that we can hit the bullet with the enemy. Let's make bullets interact with enemies. So what we are gonna have is in our game object here. Oops, I clicked the OBS. Nice. Where is game object? Game object. Let's add here a protected. Okay. Function called move, and we're gonna have how much we want to move. So let's go in here, implement this for all the objects, and what's gonna happen is we're gonna have a function inside the scene that will tell you, it will tell us if we can if we interacted with something, I suppose. And what we want, it's a really easy way to do collisions, is we will actually have like a callback function. So whenever we will touch an object, we are actually going to have a function getting called, and we can do whatever logic we want there. So let's see, detect collisions, I suppose. And you know, we can have all sorts of things. We can have here like a mask for collisions, like I don't know, collision mask, and we can decide if certain objects can only collide with other objects that of a certain type, you know. So we can do all that stuff maybe later if we want. It's not necessary for this simple game, but just letting you know. So we're gonna have a detect collisions, and we're gonna pass in our object, which is not needed, maybe. What's gonna happen is our game object will actually need here a rectangle. And I actually don't want to use Raylib's rectangle. Let's make our own stuff. Let's call it AABB. M bounds. So this is going to be like the bounds of our object. Let's put it in math, maybe. Why not? So AABB stands for axis aligned bounding box. Okay, our enemies won't be rotated. Maybe not in this game, I guess. Let's see. Float X, float Y. Well, let's have X0, Y0, X1, Y1. And let's have here like a function called update. And we pass in like a position and a size. And what this is if we go till draw, we're basically defining our AABB describes a rectangle, right? And this point, we have basically these points here. This is like the min, and this is the max, and we can actually do something like this. Like that. And do the same thing for these two. and we have this. And so this is our min point as a vector 2, and our max point also as a vector 2, and we can also take these coordinates by just saying x0 and y0, or x1, y1. So this is x0, y0, x1, y1. Okay, and what's gonna happen is our entities will move. So this rectangle will change its coordinates. It's gonna move to like here. Okay, and so we have to call this update function to say, hey, we just moved. Okay, so recalculate these. Okay, let's see. Maybe, I mean, you can do this however you want. I'm just, giving you an example on how you might want to do it. So, because our sprites actually start from the top left, right? Okay, well, let's just do this first. So, since our sprites actually start from this point here, and then the sprite is being drawn onto the screen, right? And we can change that if you want. But then the way we compute these points is simply saying, oh, well, the position is the minimum, and the maximum is simply the position plus the size, right? So this is going to be the position, and max is simply going to be the minimum plus the size. And we don't have this plus operator implemented, so let's do that. We actually let's create here a math.cpp. Let's include this and say, well, we have a we are going to return a vector 2. We have an operator plus. We want to take a left and a right vector, and we can, well, we can make it, we could have made it in the header, but I think this is a bit cleaner. And we are going to return ax plus bx, ay plus by, just like that. And this should maybe work. It seems like it does. Pretty good. Well, I'm not sure this will work actually, because this function is here, but we didn't announce that there is this function, right? So we have multiple ways of doing it. For now, let's actually put it in here. Let's just copy the function from here. So I actually went back on my word, I suppose. Let's do that. This is like the other. Okay, and we could have made it so that we change our vector, I suppose, but I don't think it's necessary. Let's see, did we mess it up? Right, so we have to remove this. We're gonna use this space later on, I suppose. Okay, enough messing around. Let's see. So we want this detect collisions, and we want to pass in the bounds of our object. So this is our ABB, and this is our amount that we want to move. So we are basically going to compute the future position out of this stuff. We could actually just ask for the future position and the size. Well, this will do for now. So let's add here a bool detect collisions with ABB bounds v2 amount of movement, or we can say that velocity, I guess. Amount, I think, sounds okay. Let's do math.hpp because we have that there. Like that. And let's implement this scene.in scene.cpp. Okay. So what we're gonna do is we are simply going to just iterate over all the objects. Okay. And obviously now we have to make some changes, but first let's implement this. We're gonna compute the bounding box for the future position. So we have future ABB, which is gonna be bounds.update, and here is the position which we can take from bounds.min plus the amount, and our size. Yeah, that's well, we can take it from here. Okay. We can add in a function here in ABB that will return us the actual width and height of the object. So get size, and we're gonna return the width, so x1 minus x0, and the height y1 minus y0. Just like that. Okay. Let's see, let's go back to scene.cpp. We have an issue. Right, so okay, my cats are kicking down the door. We have these bounds which will get updated, and so we can use this bounds. Actually, we don't have to put it. We can do this ABB future bounds, and we can do it like that. Let's do future ABB. And what's gonna happen is, yeah, well, we have multiple errors here. We should actually take the game object with us. And theoretically, yeah, we could have just taken the bounds from there. We can clean this up later. You know, when you hear this, it's probably never gonna get cleaned up. Just letting you know. I'm just training you on how it's gonna be in your software engineering career. People are gonna say that, but they're never gonna do it. Okay, so we do this. Let's put this here. And what's gonna happen is say, well, we don't want to check collisions with ourselves. So if our game object is equal to this game object, we're simply gonna continue. Otherwise, if yeah, right. In here, guys, this is freestyle, okay? This is not planned. I didn't write this code before. This is true software development, all right? Okay, this is actually public, so we can actually get it. Yeah, well, talking about good practices. If this is public, let's not pass it. Let's just take it. So, see guys, we actually changed it. I told you. Like that. So this is actually the game object bounds, and we are updating this, and we can actually use the position and the amount and the size which we should get from here. Yeah, this is a bit messy, but you know, it is what it is, guys. Let's do this like that. Now it's not going to complain anymore. Let's do if go has a bounds, and we can actually make a static function called abb intersects. And we pass in the bounds of that some other game object that we are iterating over, and this future abb. And let's suppose this function exists for now. So if these two are intersecting, we're gonna call a function from each, which we are gonna define now. This callback, which is gonna be like a virtual void on collision, you know, just like in Unity. And here we can pass in the game object with which we collided with. I think that's the right one. Okay, and we can actually pass in here more than this object. We can have a custom structure that will have this also, but can have other details about the collision, like the point where they intersected, how much they collided one over the next, so we know, you know, that those parameters. So maybe we know how much we have to push them apart, or you know, all that sort of stuff. We can have that if we want. Let's take this and let's say we have a basic implementation here, and it's not going to do anything. So, you know, objects that don't care about collision, we won't do anything with this function. And so what's going to happen is we're going to call this on collision, and the object is game object, and our game object will also need to be notified in the same manner. And we're going to pass in the game object we just iterated over as the parameter. Okay, I hope it makes sense. If not, you can sue me. I doubt you will. Static pool intersects. Okay, how do we do this intersection? ABB, AABB, B. So how do we determine if two rectangles are intersecting each other? Well, it turns out it's extremely simple. If we want, we can just Google it and you'll see a really simple function. But I'm gonna tell you the gist of it. If we have this rectangle intersecting with, with this rectangle over here, and here we have x0, y0, x1, y1. Here we have the same thing, but it's with different colors, right? So I'm using the colors to differentiate between the coordinates. That's why I'm not giving them different names. And what we can see here, obviously we have here x1, y0 because of how coordinates work in our system. Here we have x0, y1. And let's do it for red also. x0, y1, x1, y0. Okay. And so how do we determine this intersection here? Well, we will see something. We will see that x1, okay, so let's do it with red. So x1 is actually greater or equal to x0 here, okay, and additionally we have x1 red is less than or equal to the other x1. Okay, so we have this condition and we are basically doing the same thing with the y. So we have y1 over here. We can see that it's greater than y0 or equal, obviously. And here we're gonna have y1. Well, I'm not sure if this is the actual condition. Oops, messed up my microphone. Less than we are discovering, guys. Okay, I didn't write this down for a long time. So y1 is less or equal to the other y1. Okay, and I'm not sure if this was the actual formula. I think we also had to include like x0, right? But we are not doing it, so we are not touching this x0. So let's see, guys, let's explore. ABB intersection test. So this is the algorithm. So yeah, okay, so it takes into consideration the minimum and the maximum. And in our case, that's not right because we are only taking in our maximums. So we did something wrong there. So as you can see, this is the actual condition. We can see it viewed here, projected on this line. So we have the minimum is less or equal to the maximum, which checks out, and the maximum is greater than the minimum. So here we actually almost got it, I think. So we should actually change this to minimum. Okay, because I mean, it's true, right? This maximum was greater than this, and this was less than this, and the same thing happened for y. And so this should be our condition. So let's try to copy what we wrote here, and let's see if it works. Guys, I recommend you try to do this yourselves, always. In any problem you have, try to solve it on your own, and if it doesn't check out, it doesn't work, you know. I knew here something was wrong because it didn't look right to me, but I didn't do it in a very long time, so you know, I had the experience to actually know what might be the issue. So this is why I quickly found out the problem. So well, let's see, maybe I didn't find out. Let's see. So let's highlight this like that. No, like that. So maximum greater or equal to the minimum. So a dot max. Oh, right, we have to check in the, so the x maximum is greater or equal to b dot minimum. And our minimum is what we have here, less than or equal to the maximum. B dot maximum. Okay. X axis check. Let's make it a bit nice. Y axis, and we just put this like that. And we're just returning true if these two are true. So it saved us a bit of debugging time by simply surging it. So let's see if that will work. We are gonna quickly make a test, and that we can end with that we can end the actual stuff. So our enemy, where do we have it? Enemy simple. We have it here. Let's actually implement that on collision thing. like that. Good. And in GameObject.cpp, well, for now, let's just do the check and not do anything if, like, we don't really care. We just want this onCollision function being called if we hit any other objects. So if we go in the player, not the player, but the projectiles, we do the same thing, virtual void on collision, override, game object other, just like that. Let's implement it. So for the projectile, for now, nothing will happen. So we can maybe delete the projectile, right? So if it hits an enemy and it's not piercing, which we didn't implement yet, it's just gonna delete it, and we are gonna make it in a second. This is gonna be maybe a longer episode. Okay, we're gonna implement that a bit later. If we go in the enemy, we implement this, we are not getting deleted, or maybe we will. Yeah, we can just have a simple thing here like color C, and we just have this color and we have it set to red, right? If we get hit, yeah, I mean, it sort of works. Well, no, this is gonna change it to white, like from one frame to other. Okay, let's just see if it works by setting the color to red at some point. Let's implement this delete function, which we will need anyway. So this is actually a protected thing, void delete, which is simply gonna set this m deleted boolean to true. Let's quickly implement it here. Okay. Well, no, let's do the right thing, guys, for once in our life. Let's actually implement it here. Void game object. And let's make it nice. Yeah, just like that. We take this. We do that, so it's by default false. Let's actually remove it now. So in here, what's gonna happen is if after we ticked the object, we determined that is deleted. Let's implement that also, which is a public boolean. Object is deleted. Return m deleted. Okay, so if it's deleted, we are gonna append it to some deletion list. M pending game objects to remove. Push back this game object, and we also have to create this, obviously. So let's do it here. Like that. Later on, what's gonna happen is we're gonna iterate over these, and I'm thinking, how are we actually gonna remove these? So go is the actual object. I think we want an iterator there. So because we can't simply do erase, right? And why we are doing this? Why are we pending this? Because again, we are iterating over this vector while we actually want to remove something from it. And so if we started to remove stuff from it, we might mess up the iterators, right? I'm pretty sure we will. So there are more options for us to explore, but this is a really nice and clean way to do it. You just append everything that has to be removed after one tick, and then in the same tick at some point we remove the object from the game objects. Okay, and like this it's extremely clean. You can do addition and removal by simply using other vectors to keep those in, and like that you can actually do other stuff with the things you have to remove, or maybe you can delay them to be removed, like the other tick or something like that. I don't know, you can go crazy with this. So my STL knowledge will tell me I cannot just do this like that. And I think what we have to do is actually use here an iterator. So let's see, m game objects begin, and we can maybe like do a find or some stuff, but yeah, I don't know. It's different than and like that. Boy, it's been a while, guys, so forgive me for that. And here we simply add in actually the iterator, and so this is going to be a vector of iterators over this, like that. I think it's messed up, but hey, I did not make C++. Well, what I meant is I didn't make the standard library to be so shit. So yeah, okay. Let's try to actually run this and see if it works. Obviously it didn't. Let's see what issue we have. Delete doesn't exist, okay. Because this is not actually part of player projectile. Okay. Another one. Detect collision must return a value. Okay, for now it's gonna return true. Well, yeah, just for consistency, let's say we have a result here false, like there was no collision, and if we have at least one collision, we simply set it to true, and here we return the result. So we just return here if we intersected with anything at all. And oh, I actually know it's not gonna work. Let's return this, I suppose. Oh, yeah. And position amount. Actually need to move the position. For this we have to implement some other stuff in here. So we have a void operator plus equal other, and we say x plus equal other x. Same for y. All right. Let's go in the player. We just add them as we need them, so we don't flood the program with stuff we won't use. Well, not that we would care anyway, because this is a shit project, but yeah. And we are reaching the 50-minute mark in just a minute. Here we will move this, so let's do that. We have to actually move using this move function in order for us to detect collisions. So we will actually move here with we just emulated that with this. This is the vector with which we are moving. And if we go inside the enemy, we go into the tick. Here again, move, and we actually have the m direction times the speed, and we don't have this like that, and we don't have this multiplication implemented yet. Let's quickly implement it. So operator like that, and this is actually a number. Like that. Let's see, will it crash? Well, didn't even compile, so we will never know. For now, let's just say we simply return this. We might make use of that later on. So it doesn't know where this function is, so this is void on collision, enemy simple. Let's see, enemy simple. Oh yeah, we forgot to say the scope of this function. It didn't crash. Okay, we don't see the enemy, which is interesting to say at least. Did we make something wrong in here? We might just have, let's see, let's copy this code. Let's say, what did we have? So we just increased the x, right? By the directions x, which seems to me like the same thing we are doing in here. So I'm pretty sure the issue is not from here. Oh, it might just be that the color, it's not white by default. So let's do that. Maybe we just didn't see the stuff. Here it is. And they actually didn't collide, and we know why, because we added all of these things like bounds, size, right? And we never actually got to use them. So let's do it now, and with this we will actually finish the stuff, hopefully. So m size, so let's see how much. So 64 by 64 looks pretty good. Okay, and we have m bounds, which we might want to update. Well, let's make them in here. So let's create bounds using a position and a size. So let's create a constructor here. Let's make a default constructor that doesn't do anything. Let's make a AABB v2 position, posiciones, size. And we are basically just gonna call update with these two arguments actually. Like that. Where were we? We were in the projectile, right? Or the enemy, yeah. So the bounds will actually be the position and the size. And whenever we move, we actually update the bounds. So let's go in here and we say, well, and bounds update and position and size. So like this, we will update the bounds after every time we move. And why we are doing it here in the constructor is so that we have this bounds initialized even if we didn't move at all, right? So if maybe we have a game object that shouldn't move, but we still want to detect collision with it, this is what we have. This is why we have that. Player projectiles, this also needs the same stuff. Looks pretty good. Let's see. Okay, whoa, okay. So we crashed the program, obviously. Why would it work first time? Okay, I keep pressing space. So, vector erase iterator outside range. This sounds pretty bad. Let's see. Obviously, we know we are in here. So we actually tried to remove did we do something wrong? Let's see. We stored, oh right, so what's happening is we forgot to clear this list, and so the next tick, although nothing was added here for deletion, we still had the old iterator in here. So after every tick we can just, oops, Freudian slip, we can just clear the vector. Well, I'm saying lists, I'm referring to vectors here, but it's just, I know it's faster to say lists and it's nicer overall. Okay, so so we can see the bullets are getting removed. 64 by 64, it's probably way too much. We should actually add also offsets. Okay, that's a crash. We should add offsets on where we should put the bounding boxes, but for now it works, so we are gonna leave it like that. Well, actually it doesn't work, but let's see why. So why doesn't it work? Well, we have the same issue. We're trying to what's this? So we have a projectile here, and we tried to remove it, but we don't have it anymore. We have 38. Well, it's weird because it doesn't always happen. So yeah, it might be something we actually, oh, I think I might know the issue, but I'm not sure. It might just be because we extended the vector and so the iterator got invalidated. So we might not want to keep this approach where we actually keep the iterators. We might just do it using the pointers. So let's just change it now and see if that was indeed the issue. Let's go in here and let's say this is actually a vector of pointers. And I know this episode is really long. I'm sorry. I'm sorry, guys. Please forgive me. Okay, let's see. We will not do it like that anymore. Game. Well, this should be game objects first of all. I just seen that like that, and we add in the pointer, and here what's gonna happen is say, well, and this is very slow. Okay, this is not how we would normally do this, but we are just using this, okay, as a a faster way for us to implement whatever we need. Although the game would be slower now. We could use other things that are way faster for us to do it, but for now this will have to do. If we have any issues in the future, we can just change the implementation and that's it. Like, it's not gonna take us that long anyway, probably, and we are probably never gonna have any performance issues. Okay, don't fix it if it's not broken. Okay, so what do you want from me? Like, you want that, and can I do it now? I think I could have done it like find if. No, actually there is a remove if, I think. Well, there is one, but yeah, whatever. Do you still crash? You know what? It doesn't crash. We should also detect when things are outside of the bounds. But for now we don't care. Okay, it doesn't crash anymore. So you have it, guys. We can finally stop this shitty video. See you next time, guys. Have a nice day. Bye bye.